All right. So first thing I'll say is I apologize I don't have your tests graded yet. Being gone at a retreat with our majors prevented me from having enough time to complete that over the weekend. I'm sure some of you who are on that retreat can relate with trying to catch up on all of your work that you were missing over that same period of time. So that should be ready by Wednesday's class. I'll hand those back to you. So instead, what I want to do is start looking at some more realistic examples and using our simplex method to look at them and solve them. So what I thought we would do today is we start by going through problem 4.3. So bring out your laptops, bring out your textbooks, and we're going to go through that example together in class. And we'll go from there. All right, here. All right. So, how many people have their textbooks? I don't see a lot of textbooks.
I got one
at this
here.
point. Awesome, man.
Thank you.
All right. Does this table have one? No. Does that table have one? All right. All right. So let's start. Get around a textbook if you don't have one handy and read the problem statement so that we can start figuring out how to put this into our system. 4.3. And then just catch my eye so let me know when you're done reading that one.
Are we supposed to be there like some
It's basically that's what I used, but I really would like yeah, but I had something much more about it. I was like, I have to run a macro, but all right, who needs more time? 4.3. All right. So what's the first step that we said we want to do each time we go through one of these problems? Step 1 is define our variables. So what are our variables in this problem? What are we trying to figure out what we should do? What's one thing that you think we need to figure out? Yeah.
We're trying to figure out how we should assign our capital loans.
Okay, so that's the overall strategy, right? How we assign our capital to these different loans. So in particular then, how do we break that up into a bunch of variables? All the different types of loans. So what's one of the types of loans? Automobile loans. Okay, and in what way are we saying we're going to allocate it to loans? Are we talking about percentages? Are we talking about dollar amount? Are we talking about pure number of loans? What are we measuring in this problem? What are we trying to decide for these automobile loans as an example?
Could we do amount of money or percentage?
We could, and actually, I am hoping to actually examine both of those. Yeah. So how is the problem stated?
How to allocate the money?
Yes. So is that in a dollar amount or in a percentage?
I would think so,
Dollar amount. So it's initially done in dollars allocated for auto loans, right? And I'm serious when I say don't be afraid to be verbose in these models. You don't have to keep typing dollars allocated for auto loans all over again like you do in the simplex method, right? So make it readable, make it sure that you understand. What's the next thing that we're trying to figure out? That's not the only loan option available to us, right?
Furniture loans.
What was that?
Furniture loans.
Okay.
Dollars allocated for furniture loans.
I can spell. Furniture. Okay, what's a third type of loan?
Other secured loans?
Other secured loans. Okay. Any other types of loans?
Signature loans.
All right. Are there other loans?
We got some risk-free loans.
Some mystery.
Risk-free securities.
I don't see that.
It is.
What, risk-free securities?
Uh-huh.
Is that what I put for a G on my? See that? So look at what I have on my paper is unreadable. See? Securities, you said? Are there any more? But notice we've already got 5 variables here. This is already a more robust example than we've looked at all so far in the semester. So you can see this is going to be more complicated, and you can already be happy that we're not doing the simplex method with this, right? This is 5 standing variables. Then we would have some additional slack variables, maybe some artificial variables on top of that, right? Yeah, yay for computers doing their computation, right? Okay, what are we trying to do? In English, what do we want to do? Okay, and we'll come back to how to do that right here, right? But we need to see what our constraints are. So someone in this table right here, give me one of the constraints that we're limited to.
Risk-free securities have to be less than 30% of the total.
I can type. Okay, so now let's try to put that into an equation. Let me make that a little bit bigger here. Something like that. So how do we say that risk-free is less than or equal to 30% here? So what is the total going to be? Well, hopefully it'll be 2 million. Does it have to be exactly 2 million? We hope that becomes a binding constraint, but it doesn't have to be. So let's write our equation without the knowledge of that binding constraint. Okay? So what is the total going to be? How do we know what the total number of loans is going to be, given the variables that we have in front of us here? Yeah, so it's just going to be the sum of these, right? And so if I were to use single letter variables, I might do like A plus F plus S plus G for signature plus R or security, so I don't know, risk-free or whatever. That's going to be our sum, and if we take 30% of that, right, the risk-free has to be less than or equal to that, right? So, but this is not the format that we put into our models, right? The format that we put into our models are variables over here, some like less than or equal, greater than or equal, whatever, and the right-hand side constant, right? So we need to reformat this to look like that. So let's figure out how to do that real quick. So if we did this, R is less than or equal to, now we can do 30% of A plus 30% of F plus 30% of S, 30% of G plus 30% of R, right? And now we can then subtract all of these, right? Wait. Yeah.
Why can't we do it of 30% of 2 million?
Because this constraint doesn't say that it's of 2 million, right? This constraint just says it's 30% of the total. We want to be able to use less than 2 million. Now, you and I can quickly read through this and say, well, the most optimal way to make money is to give out all our loans possible, right? But the way the way this constraint is written is that it doesn't have to be 2 million. We could choose to do less than 2 million. And so we want to separate out those two constraints from each other. You're embedding some quick to see knowledge into this that isn't technically in this particular constraint by combining two constraints together.
Well, it says the total funds available for investment, and it says there's 2 million available for investment.
Right. So that's a separate constraint.
Okay.
Mm-hmm.
Okay.
Yeah. Okay. So now what we want to do is we're going to subtract all of these. And so this is 100% of R minus 30% of R gets us 70% of R. Minus, and then we can do 30% of A, minus 30% of F, minus 30% of S, minus 30% of G is going to be less than or equal to 0. And now we've got an equation with our variables on the left-hand side and a right-hand side constraint with a simple constant in front of it right there. Okay? And that's what we're going to put into our model, is this equation rather than this one, which more closely matches the English wording that we put on there. Okay? And it's important that you do this because the solver expects a constant on the right-hand side. If you put variables on the right-hand side, it is not guaranteed to work for you. Okay? Sometimes it does, but you get lucky when that happens, so you don't want to count on it. Yeah, Jason.
What determines the criterion for when it can work with a variable and it cannot work with a variable?
It has to do with the certain mathematical characteristics of the matrix that's being represented in there, and whether it can pivot the right way or not. So it's best just to keep it constant. It's not something that you can a priori know. So let's put this equation then in there. So the left-hand side equals 70% of our risk-free loans. Well, that is B5 minus 30%, and I'm gonna distribute this 30% out now, back out. B1 plus B2 plus B3 plus B4. So you get 70% of this minus 30% of these is what we said this equation is going to be right here. And we can check to make sure that works. We can put in some numbers. Let's do $10,000 here. When do we get there?
To expand the breed
Yeah, we can. 50,000. 90,000. Whoop, fine, 900,000. 25,000, or 250,000 if I. And what's 30% of that? Let's do like 300,000. Let's see what that is.
Like 0.7 times B5 and 0.3 times.
Well, it's because it's
Yeah,
because it thinks it's a percentage,
Oh,
right? So if I take out the percentage there, just make it a number. There we go.
Yeah.
It doesn't matter what format that is in. We got the right equation, right? All right, so that's our first constraint right there. What's our next constraint? Back on the, right there. What's another constraint?
Signature loans may not exceed 10% of the funds invested in all loans.
Has to be less than or equal to 10% of loans. Okay. How is that different from the previous one? Other than obviously signature versus risk-free. Yes.
Does it only include loans and not the risk-free securities?
Correct, right? These are not loans, and so we don't include that. So we're computing 10% of these other four values. We don't include the risk-free securities in there, right? So we will do the same thing as we did right here. But instead of getting 100% minus 30%, we're getting 100% minus 10%, right? So you get 90% times, now this is our signature loans, which is B4, right? Minus 10% times our other three, B1 plus B2 plus B3. Right, so now we're not taking into account our risk-free securities here. We're saying that 90% has to be these right here.
How did you know to do 90%?
Because I did the same type of transformation as I did here, but instead of it being risk-free and 30%, I did signature loans and 90%. So this became 100% minus 30%, which was 70%. Our new one is 100% minus 10%, which gives us a 90%. Okay, this table over here, what's another constraint that we have for this problem?
Furniture loans plus other secured loans may not exceed the automobile loans.
Okay, furniture plus auto, you said? No, other
Plus other secured loans, yeah.
is less than or equal to auto?
Yeah.
Okay, so this is going to be a little bit easier transformation, right? We can just do the furniture, which is B2, plus the other, which is B3, And now we can just subtract the auto to move it to the left-hand side of that less than or equal. Minus B1 has to be less than or equal to 0. All right. Up front here, what's another constraint that we have?
Other secured loans plus signature loans may not exceed the funds invested in risk-free securities.
Other plus signature
Yes.
cannot exceed,
The funds invested in
In
risk-free
risk-free.
securities.
right? So again, this one's going to be pretty easy because we can just add those first two and then subtract the third to move it to the left-hand side of that equality. So other is B3, signature is B4, and risk-free is B5. All right, back corner. What's another constraint? What's another constraint for this problem?
All of the loans together should be less than 2 million.
Yep. So all the loans are all everything all together.
Everything all together.
Yeah. Costs less than or equal to $2 million, right? So here's where I am going to take advantage of Excel and not have to type in a bunch of equations here, and I'm just going to use our sum function here, right? So I can just sum these values. Right? I just want the value of all of those together to be less than or equal to 2 million. Up front here, what's another constraint that we have?
We're not sure.
Not sure. Does anyone want to help them? Logical constraints are there. That's a freebie, right? Cool thing here is we don't have to enter logical constraints. Is there anything else left? My notes include at least another constraint. What's that? I heard.
It's implied. Each one is greater than or equal to 0.
That's the logical constraint. Is there one that limits how much you can spend on any given?
You can't spend more than 2 million.
Yes, I have that. We just did that one, right? I have in my notes that there's something that can't exceed 600,000. Huh?
30%.
30% of what?
Well, that's your 30%.
Oh, okay.
Aren't those implied or yeah?
Yeah, that's implied. Okay. So I can't even keep track of my notes. All right. All right. So good. So we want to compute our objective function then. No, 30% of yeah. I'm still stuck on that. All right. So what are the returns for each one of these? What's the return on the auto loans?
8%.
What's the return on the furniture loans? 10%. What's the return on the other secured loans? What's the return on the signature loans? And what's the return on the risk-free securities? All right? Now the reason I entered this in here is we could, in this objective function, we could take the dollar amount that's in B1 and multiply it by the value that's in D1. And that would get us our return for auto loans. Right? So if I had $1,000 in auto loans, I get $80 back. Right? Which is nice. And then we could do the same thing. We could do plus B2 times D2. Right? So if I made, instead of $1,000 on auto loans, I made $1,000 on furniture loans, I'd make $100. Right? That's 10%. And I could keep repeating that for this whole thing. Okay? But that is easy to mistake, and it gets cumbersome as the number of variables increases. So one of the other Excel functions that is given to us that you will use very, very frequently in this class is what's called sum product. Okay? And what sum product does is it takes two arrays, in our case, and it will take all the elements in the array 1 and it will multiply it by all the elements in array 2. So whatever's in here, it will multiply it by this value. Whatever's here, it will multiply against this. And it will do it for all those. That's the product part of the sum product name. And then the sum is to take all those values and add them together. So what I'm going to do here is I'm going to take array 1, which is the amount that we're going to put into our loans, put a comma, and then I'm going to highlight this second array right here. So I only have to do those two things once. And so now we can see what happens if we do 1,000 units, $1,000 for each of these things. You see, every time I added $1,000 to one of these, this value updated right here. And this should be right. This is 80 plus 100 is 180, plus 110 is 290, plus 120 is 410, plus 90 is 500. So that adds up the way we expect. Obviously that's not perfect checking that we did it right, but it at least gives us a sense that we've given a good first attempt, right? And so now we've got our model inside of our Excel spreadsheet. Let's go ahead and have Excel Open Solver plugin solve it for us here. All right? So let's go to do that. We're going to click on our model button here and bring this up. Where is our objective cell? B7. So I'm going to click on B7 there. And are we maximizing or minimizing? Maximizing. What are our variable cells? Yeah, B1 through B5. Right? Those are the values that it can go ahead and change. All right? And then, let's see if I can do this here. Our constraints here. I am going to do the add one constraint since these are all less than or equal. I'm going to highlight our left-hand side of our equations here, change it to a less than or equal constraint, and highlight these values here, and add that constraint. Right, so now what I have is I have these B9 through B13 are going to be less than D9 through D13. Exactly how we want it to line up there. And I am going to have it output the sensitivity analysis. Save the model. And now we can see really nicely, these are our variables that we're doing a maximization. and that these constraints are less than or equal to these values right here. All right? Before I go on, I want to make sure everyone is caught up with me. Does anyone need more time to enter their model into their laptop here?
Can you open the solver again?
Huh?
Can you open the solver again?
Yes.
We talked about how my computer will do this one.
Mhm.
It doesn't work at all. The old version.
To
of the
open,
software.
it should, because we're not doing anything special here.
Yeah, it's not. It's like completely.
We'll have to check it out after class.
Right.
All right. So let's go ahead and click on solve here. And we have our solution here. Okay? What are our binding constraints? Can we tell from here? How do we tell which ones are our binding constraints? It's easy to tell from our sensitivity analysis, right? Which ones are our binding constraints? How do we tell if something is a binding constraint? It has a shadow price, right?
They all do. They're all binding.
They all do. That means every single one of these is binding. Okay? That means if we change anything about any of these constraints, it's going to affect our optimal solution. It's like if this were a 2D problem, all the lines are intersecting at that one optimum point, right? But it's not lines, and we're not two-dimensional anymore, right? Okay, so what does this mean? Let's look at these shadow prices. What does this shadow price mean? 0.008. If we change what? If we change what by 1? The right-hand side by 1. So if we could increase the amount of risk-free loan, right, we could increase the overall price by 0.008. That would be our objective function.
If we do it by dollar amount though, so would that mean like if we added $1 more to the risk-free loan?
No, because this right-hand side is not a dollar amount, right?
What is it
This is, well, because we rearranged it here
then? Yeah.
to like this, it's a 0. So it's the difference in this allocation. So I guess yeah, it would still be a dollar amount, but
Would it be
But it's not
$1 or
written.
would it be
yes. So it would.
30%?
So if this was 1, this is not in terms of a percentage, right?
Right.
This is in terms of still dollars, right? So if you would increase this by 1, you'd be the difference between that 70% of the risk-free and 30% of that.
Okay, so it'd be if we said you could spend $1 more then 30%.
Yes.
Okay.
hmm So this is still in dollars, so it'd be $1 more than 70%, rather than 1% more.
Right.
Then our objective function would increase by, oh, it's helpful if I use the right computer here. Our objective function would increase by 80 cents. So for every dollar we can use more of risk-free securities, we can make 80 cents. Because it's 0.8%. I mean, so this is the marginal cost of each one of these constraints in our solution. Yes?
So if you were to invest $1 more, you would make 80 more cents?
No, that would be down here. right? This is the constraint. This is the constraint that represents total cost, right? So if we increase one more dollar, we would make 9 cents.
Sorry, $1 more in risk-free.
Okay, so one more dollar in risk-free over the 30% limit, yes.
Then
Mhm.
would make 84 cents.
Then we would make, I'm sorry, 0.8 of a cent.
So that would be pointless.
Not pointless, $1 would still make us money, right?
It would, that's
Yes,
profit.
that is profit.
Okay.
Yeah.
This is if we invest $1 overall, we make 9 cents. So
If we allocate that dollar in the same way.
yes.
Okay.
So if we could invest not $2 million but $3 million, we would expect to make whatever 9% of $1 million is, right? So we'd expect to make 90,000 more dollars. Okay?
If they're constants, they're
And this can increase as much as we want, right? So this tells us if we could change these constraints in some way, right? How much additional benefit it would make us. So if we could increase this value right here, or increase this value, how much would it increase the overall profit? And this is probably the one that we're going to look at most. If we just have more money to invest, how much is it going to profit us? Well, these all make sense. Okay? What are these values right here? Yes.
I have a question
Uh-huh.
about increasing the cost. So like since we're making money, would
Yes.
we not just, would that mean just increase the money put in until we get hit the range?
Yeah, which is
So like that would be the thing to do as like a company, like,
yeah,
okay.
yeah. So but here's the thing. Maybe we don't have $2 million. Maybe we have $2 million.
Right.
Let's say we have the opportunity to borrow another $1 million. Okay? What interest rate should we be willing to pay for that extra $1 million?
Less than 9%.
Less than the 9.4%. So if we can borrow money at 5%, we should do it because we can invest it and make 9%. So that we can make a total profit of 4%
Okay.
on that money. Okay, so it's not just, because money doesn't come for free, right? We don't just, wow, I walked up to a pile of $1 million, right? We have $2 million available to us. Should we pursue an additional amount of money available to us? Now it gives us the answer. Yes, if the marginal rate of return is less than the 9.44% that we expect to make on these loans. Okay, and so that's how the shadow price can really help us. Right? Make that decision. Okay? What do these numbers represent? Let's back up. What do these numbers represent? The rate of return for each one of these loan types, right? So these represent the rate of return if the auto loans is between 1.8 and 29.9%, we're going to get the exact same allocation strategy. Right? Or if the furniture loans are between 0.5% and 2%, oh, that's how much you can add. Yes. Excuse me, let me start this again. So if we add, so if this is between, let's pretend that's 0.2, between 6% and 39%, the overall allocation strategy is not going to change. So that means that we've got this large range for auto loans that if we just add more percents, we're not going to get more auto loans. But you talk about this one right here, the furniture loans, it's got that narrow band, right? We can only subtract off 1/2 of 1%, or add up to 2% right there, right? So between 9.5 and 12%. So if the furniture loan range change went up above 12% or below 9.5%, that would change our allocation strategy. So it tells us in a changing interest rate market, which of these allocation strategies could be affected, right? Because these interest rates are probably tied to some master rate, whether it's some U.S. government loans or some other index that you say your furniture loan is 5% plus this base rate, and if that base rate changes, then it's going to change what you can give out or what you can expect to receive from furniture loan. And so what this allows us to see is when those changes take place, how much before we want to change where we allocate our funds to. Because that's that sensitivity. This furniture loan is much more sensitive to the interest rate than the auto loan is to its interest rate. Okay? So we can be looking forward to seeing how that takes place as well. All right. The other nice thing that we can do is we can ask ourselves questions. Well, what if the interest rate changes over time? So let's say we say that the other secure loans. What happens if they go above 12? They go to 12%, and the signature loans go to 11.5. Just give ourselves some more decimal places there. There we go. Now, I've changed two values, right? I've changed the value of our other secure loans, and I've changed the value of our signature loans. So now we can't consult this anymore, right? Because these values are only true if one of these is changed. And I've changed both these. I've changed this from 11 to 12, and I've changed this from 12 down to 11.5. Right? So we don't know, even though 12 is within that allowable increase, and 11.5 is not in that allowable increase, we don't know because we've changed two and not just one. So if we go back and resolve it, let me here. I'm going to take those values real quick. I'm going to paste the values right here. Then I'm going to go ahead and solve it. And you can see that those values didn't change. Right? So in this case, even though the ranges were out, I changed this one outside of its range right here. Because we changed two, we kept the same optimal solution. We did our same allocation strategy. We made a little bit more money because of the different interest rates, but our solution was the same. We allocated the same amount of money to each one of these two. And we could do other things. We could go even further. Yeah, well, these books were written back in a time where people could actually make money on loans.
I was going to say you can't do that.
Not in the same way. Okay? let's go crazy and go 16% for these signature loans. And you still have the same optimal solution, okay? So these models allow us to be able to do these kind of what-if scenarios that Excel is really known for. What happens if this scenario, I might have an economist on my staff that's saying there's 30% chance of this happening, 40% chance of this happening, and 20% chance of this happening. You can encode that into these values here, put the interest rate, and see what's going to happen, right? So you can make these informed decisions about what's going to take place. All right. We're almost out of time, so I'm not going to answer the percentage versus the return because I want to quickly look at problem 4.7. So if you turn your page over to problem 4.7, this is what your homework for Wednesday is going to be. Can someone turn on the lights for me, please? I'm not going to do any more on the screen. Okay, there is a problem like this in your textbook. So if you're a little bit confused, make sure you read your textbook before Wednesday's class. It goes into this. But what you're doing here is you're doing a cash settlement solution. So you're working for a company, I forget what, Hawthorne, is that the name of the company in this example? And you've been sued in court successfully, and you have to pay out a cash settlement for this suit. And so you're trying to figure out how much you should save right now in order to minimize the expenses to your company. Okay? So you have two options. You're only going to be able to buy government securities because they're the only ones that the court assumes are going to guaranteed be available at any given time. So you can't invest in some company because it might drop in price between now and when you need to pay it back. So for those of you who aren't familiar with how bonds work, there is the par price, which is how much that bond is worth when it comes due, right? So if you lent money to a company, the par price is how much they pay you back at the end of that time period, okay? And the par price for both of the government securities you have is $1,000, but that doesn't mean that's how much you purchased the security for, okay? So you can buy it for a different amount than you receive at the end. So there's that purchase price is listed for these government securities. Okay. So what you're going to do is you're going to make some deposit to your bank. Let's just call it F to be consistent with your textbook. This is the amount that you're going to put in the bank. Okay, and you're going to want to buy, say, G1 and G2 number of securities. Okay, so this is dollar amount, and these are securities that you get available to you. Okay, so what you need to do then is you have to figure out how much interest you make at the end of each year and make sure that it is enough to make that year's payment. And that in the end, the second year, there's enough interest to make the second year's payment. And you go on, when that bond becomes due, you get the money back from those bonds. So for the first year, you're going to have a settlement of $190,000. So we'll just subtract off $190,000 right off the bat. You have to pay that $190,000. Also, I'm doing this in thousands of dollars. You have to buy your government securities. Right, and the purchase price for this government security is $1,055, whereas the purchase price for this is $1,000. And this is how much you have left in your savings at year one. Right? So everyone follow? This is our starting amount, our first payment, purchasing of our government bond issued 1, purchasing of our government bond issued 2, and this is how much we have in savings at the end of year 1. At year 1, we subtract off the first that payment, $215,000. Okay, and you are going to get interest, right? You're going to get interest from this at this rate, and you're going to get interest from this other one plus you're going to get interest in your savings account. So this is what you started with. You subtract your payment, you add your interest from your government bond 1, you add your interest from government bond 2, you add your interest from your savings, and that's what you have at year 2. And you need to repeat this kind of process through all 6 or 7 years, I forget how many years it is, 7 years, to make sure that it matches, okay? And then you need to solve that set of equations for what F, G1, and G2 should be. What do you want to do? Minimize or maximize anything? Is this a cost or a profit? It's a cost, so what do we normally do for costs? Minimize. And where is our cost reflected? This is our cost, right? That's what we want to minimize right here.
And when I went to UC, I got